Welcome back to the IEA's podcast, Everything Energy. I'm Dan Hewitt. This week, the energy cost of keeping cool. Wherever you're listening, there's a good chance you've just lived through a heat wave. In India and Pakistan, extreme summer heat arrived as early as April. The UAE recorded its hottest ever May, and in the United States, almost 130 million people lived under a heat warning in June. As temperatures soared, so did the strain on electricity grids. In France, electricity demand in July went up by 20% in just one day. But how fast is global demand for cooling rising? What could that mean for energy markets? And what steps can governments take to help? To discuss this, I'm joined by Brian Motherway, head of the IEA's Office of Energy Efficiency and Inclusive Transitions. Brian, thanks for joining us today. Right, I think the obvious point to start with is, why is an energy podcast like this one, why are we talking about cooling?
Well, first of all, we're all talking about cooling because it's hot, right? And, here in Europe, other places we're experiencing heat waves. It's in the news. People are suffering. They want to be cool. Of course, for billions of people around the world, this is a daily reality, and it has been for years, where they live in very hot places and they're looking for ways to be cool. And ways to be cool involve, in many cases, buying fans, buying air conditioners. People are doing that entirely understandably. It helps them be more comfortable, more healthy, but it has energy implications. Growth in air conditioning in buildings is the biggest driver of building electricity demand because more people are reaching a point where they feel the need to buy an air conditioner, or they can afford to buy an air conditioner. These are bringing many benefits to people, but it has huge implications for electricity and energy systems. It has questions around affordability and access and equality, and it has questions for the climate. So it's right that we're talking about this in a spirit of how can we bring cooling to people in ways that is both affordable and sustainable.
Right, now before we go any further, let's just define our terms. So tell us exactly what sort of air conditioning, what sort of cooling units, what are the ones that we're interested in?
Well, I guess for millennia, people have tried to be cool in hot places. And let me talk about it in three levels. First of all, how do we design our cities and our environments, to be cool? Basically, are we putting trees in cities? Are we creating shade? How are we doing all that? Recently in Paris, it was very hot. And in the centre of Paris, it was 7 degrees hotter at night than just a mile outside in a park, so the heat tends to, concentrate in cities. It makes it hotter and, makes it less comfortable for people. So you can design cities better when you recognize we're living in a warming world. Secondly, then you can design buildings better. Are you building buildings that are well shaded, well oriented? Have they got good insulation? Have you got good windows? Insulating and building a building to stay warm in the winter is pretty much the same as stay cool in the summer, right? And if you build a building really well, you can reduce the indoor temperature by 8 or 9 degrees at peak. And you can reduce the energy cost of cooling by up to 80%. I mean, we look around, in this part of the world, and we see these glass tower office blocks built around us that then create tremendous cooling needs. Glass blocks are great for ripening tomatoes. They're not so great for making a comfortable working or living environment. And so we really need to think about how we're designing our cities and our buildings. Then we talk about active cooling, which is basically plugging something in to make my room or my house or my office cooler. And we're talking about fans, we're talking about air conditioners. Fans may be less effective, but massively lower amount of electricity use, more affordable to billions of people around the world. And then air conditioners. Air conditioners use 40 or 50 times as much electricity as a fan. People are buying them at the rate of about 5 air conditioners sold every second around the world somewhere right now because people want to be cool. It's a good thing that more people are getting access to that cooling, but of course it has huge implications in terms of the electricity demand, the affordability, the climate dimensions, and that's why this is an energy policy question.
Right, let's talk about how fast demand is growing, because I think people are aware that data centers, for example, use a lot of electricity, but how much global electricity demand comes from cooling, comes from air conditioning systems?
Demand for electricity in data centers is clearly growing very fast, and it's right we focus on it. But today, data centers represent 1.5% of global electricity demand, whereas cooling represents 9 or 10%. We are installing more air conditioners and fans. We are using them more, and that is really pushing up not just overall demand across the year, but really peak demand, which is a key issue as well. Because on a hot afternoon in a certain place, everyone gets home from school or work, turns on their air conditioner, and the pressure in terms of peak demand on the system system can be really strong. So it really is an issue that needs focus.
And can you give us a bit of historical context? How much has the demand increased over recent years? How much is this a relatively recent story? How much is this something that goes back decades?
Well, there are parts of the world where it's been normal to have an air conditioner in pretty much every house for several decades. That would include Japan, US, where pretty much 90-something% of houses have an air conditioner. In fact, typical house in US or Japan has 2.5 air conditioners because they have several dotted across the house. In other parts of the world, like here in Europe, it's more like 20% because, up to recently there wasn't the same interest in cooling, I guess, because the temperatures weren't so high, and so it's a lot less common. Now, of course, it's much more common in Southern Europe than in Northern Europe, but it's driven by climate. Do we feel the need to buy an air conditioner because we're hot in the summer? In many parts of the world, for half the global population, for 3.5 billion people, they live in places that are always hot every year, always excessively hot, but actually air conditioning ownership there is more like 15% on average because people simply can't afford it. So we have a real equity issue here between places where cooling solutions are really needed versus where they are affordable. And of course, those areas are becoming richer. And rightly, people then, they say, I can now afford an air conditioner, so I'm going to buy one. So 14 million air conditioners were sold in India alone just last year because people reached a point of either exasperation with the heat or becoming wealthy enough that they felt they could afford an air conditioner. All those air conditioners are getting plugged in and used. They're using electricity. They're putting pressure on the system. They're costing people money to run, so that we have a real growth centre here that needs action now, because those 14 million air conditioners that were sold last year in India, were they efficient or inefficient? If they're efficient, they can be cheaper to run, more affordable, lower impact on the system. If they were inefficient, for the next 2 decades probably, they're going to be costing more, putting more pressure on the system. So governments have a real moment now to act, because we're locking in a lot of this energy demand one way or the other.
I want to unpick just a few of those thoughts there. So you were talking about regional differences. Why is that the case? Why in Europe is it not normal, not traditional to have air conditioning units? Is that just something that's developed over time? Because as you said, places like Japan, places like America, it's much more normal.
Yeah, I moved to Paris 10 years ago, and it was a very hot summer, and everyone said to me, this is really rare. It's never this hot in summer in Paris. And it's been that hot in summer in Paris nearly every year the last 10 years. So the climate is changing, right? And in Europe, it's really feeling that. And so many parts of Europe where they just didn't feel, why would I bother spending all this money on an air conditioner because it might get hot 2 nights in the summer or whatever else, that's starting to change. And in the recent heat wave in France, Google searches for air conditioners went up by a factor of 10 during the heat wave, because people suddenly started to think, well, actually, maybe I do need to think about buying an air conditioner or a fan or whatever else it is. In many parts of the world, as I say, it's clear they need cooling solutions and they would love to have an air conditioner, but they simply can't afford it. In parts of Africa, you're kind of 5 or 10 times more likely to own an air conditioner if you're in the richer cohort than if you're in the poorer cohort, because both for affording to buy such a machine and then pay the energy bills to run it, it's simply out of reach for billions of people.
Okay, so there's a big equality issue when it comes to people having access to cooling systems.
Absolutely, and I think we need to keep this in global focus. For many people, it is literally a matter of life or death. There's something like 500,000 excess deaths every year due to heat issues. People are sweltering, people are suffering. It's affecting their health, it's affecting their ability to study, their ability to function, and we really need to think about finding ways to provide solutions for people in ways that are both affordable and sustainable.
Now, you mentioned heat waves there. So I want to talk a little bit about what happens to the grid during a heat wave. So when the temperature goes up by a degree, for example, what is some of the strain that could put on the electricity grid?
Well, let me talk about India here, because I mentioned that's an area where air conditioner ownership is going up for entirely understandable reasons. People are getting wealthier. They want to address the fact they're living in hot places, and so they're turning to air conditioners as well as other solutions. Now, this has implications for the grid. We track this quite closely, and in broad terms, if it's 1 degree hotter on a summer's day in India, peak electricity demand goes up by about 5 or 6 gigawatts. Putting that in context, that's the max peak demand demand of Ireland. So just by going up 1 degree centigrade on a given day, an extra Ireland is added to the peak demand in India. And by the end of the decade, that'll probably be twice that, 12 or 13 gigawatts for every degree. Now, recent heat waves in India were more like 4 or 5 degrees hotter than the normal. So we're talking about 50 gigawatts more on a given afternoon when everybody comes home and plugs in their air conditioners. That puts tremendous strain on the grid. And there's a question of whether grids can handle it in terms of that extra load. As well, of course, then that's costing people a lot of money to pay for that electricity. It's emitting a lot of carbon from how the electricity is generated. A key issue here is, what kind of buildings are those air conditioners being installed in, and what kind of air conditioners are being installed? Because as I mentioned earlier, if you put an air conditioner into an inefficient building, you might be using 5 times as much electricity to try and keep cool as if you put that air conditioner into a building that's well insulated, well shaded, has decent windows and doors. So you can already massively reduce the cost of being cool just by having a well-built building. And then there's the choice of the air conditioner you buy. In any given market, whether it's India or France or Southeast Asia, if you look across the range of air conditioners for sale, some are literally twice as efficient as others. So you could be looking at 2 air conditioners in front of you in the shop. One of them is going to cost you twice as much to run because it's half as efficient as the one beside it. And generally, people aren't really aware of that. It's not something they think of when they're buying the machine. They might just end up taking one home that's actually going to be very burdensome for them and for the grid for decades to come.
Are there any stats that we can talk about that reference if we can increase efficiency, then it will reduce strain on the grid? Because you mentioned how much of the electricity demand comes from air cooling units. So are there total stats that we can look at to say, well, efficiency could reduce strain on the grid by X amount?
Well, even just if I again talk about India in the very, very short term, we know how many millions of air conditioners are being sold right now. And if you look between now and 2030 and you compare, what if all those air conditioners are at the typical efficiency they're being sold today? Or what if all those air conditioners sold in the next 5 years in India are at best in class in efficiency terms? The difference then in the peak electricity demand in 2030 from cooling is more than 20%. The peak would come down by 20% simply by the act of making sure that everybody who's about to buy an air conditioner buys an efficient one.
We've been talking about strain on electricity grids. So what are some of the consequences during a heat wave of everybody using cooling units? What are some of the examples we've seen where the grids haven't been able to cope?
Of course, we're talking about strain on grids, and you can talk about that in a local level where simply in a local village or street or whatever, just the system can't cope with everyone plugging in their air conditioners. You can talk about grids as a whole just simply not being big enough. There isn't enough electricity supply to meet demand. There are parts of the world, for instance, in the Middle East, where on a hot day, 60% of total electricity demand in the entire system is coming from air conditioners. This is how big the demand can be. And our systems in all parts of the world are ready to cope with that. And of course, you're then talking about much higher energy use than needs to be the case and much higher carbon emissions than needs to be the case. Because as we know, generally, when grids are pushed to their limit, you're bringing in the least efficient power stations, you're bringing in the most polluting, most expensive power stations. So you're just basically ratcheting up the total environmental impacts in terms of carbon emissions, costs for everybody, costs, and just pressure on the electricity system.
Okay, we've spoken a bit about efficiency and how important that is to stop people locking in inefficiencies for the long term. Is there anything else that governments can do, anything else that policymakers can do to help bring down electricity demand that's coming from cooling units?
I think, first of all, governments need to recognise, as many are doing already, that we're moving into a warming world, right? So places where they didn't think about cooling, they don't necessarily have policies. Maybe their building codes are designed more to think about keeping buildings warm in the winter, not cool in the summer. All that needs to change. How they design their cities needs to adapt to this new future we have in a warmer world. You know, half the countries in the world today have no building codes, right? So a building that is built is not subject to any level of performance in terms of energy efficiency and energy affordability. So people are building buildings that are just going to be less comfortable, more expensive to stay cool in, stay warm in, or whatever else. And governments can put standards in place that actually don't make the buildings more expensive to build, but really make them much better environments for the future. Similar for air conditioners. Most countries in the world do have air conditioner standards. So there's a minimum standard below which you're not able to sell an inefficient device. But a lot of those standards are out of date because the technology is getting better. And if a country put a minimum standard in place for an air conditioner 10 years ago, it's certainly out of date, and the devices have got better. And as we say, IEA is collecting data from markets. We're literally looking at what's being sold in shops in different regions of the world. How efficient are they? How expensive are they? And there's a real conundrum here, because you can see two devices that actually cost the same amount of money to buy, give the same level of performance, but one uses twice as much electricity. And that's terrible for everybody. That's terrible for the people who buy it and then have higher bills. It's terrible for the electricity grid. It's terrible for the planet. Now, why are people buying something that is twice as costly to run? It's usually they don't know the difference. They're not really thinking about it. They're saying, I want to buy an air conditioner. It's hot today. I'm going to buy one today before I go home. They're not necessarily doing the research, or they're not getting information. Sometimes retailers are promoting certain versions that are not necessarily more efficient. So again, there's a role here for government to protect consumers and empower consumers so that they can understand the choices they're making. They're free to buy something that's going to cost them more to run, but I doubt if many people are doing that knowingly and willingly. I think that most people just either haven't thought about it, or don't have the information they need, or maybe are assuming that if everything's for sale, it's the same price, it probably performs the same. But actually that's not the case for many appliances, particularly not the case for air conditioners. And the good news about all of that is it actually takes relatively small amount of government action then to inform consumers, empower consumers, make sure the choices available to them are all efficient. But it's important that governments do that now, because 5 air conditioners every second are going into homes. Are they efficient? Are they not? And that has implications for decades.
Looking ahead to the future, so what are we expecting to happen to energy or electricity demand coming from air conditioning units? What are we thinking that's going to happen over the next 5-10 years?
I think in the next 10 years, we could see the total cooling energy demand grow about 2/3 from where it is today. And I think no one could deny we expect more people to want to be cool in a warmer world, in a world where more people are reaching a point where they can afford it. And then it's a question of how do we empower that, how do we enable that, but while watching that does come with implications for electricity grids, for energy systems, and just for making sure that people have that access to cooling in an affordable way. For many people, many more people today are buying fans because they're much cheaper to buy, much cheaper to run. People, when they get to a certain point, want to buy an air conditioner. There are many simple behavioural measures people can take. If you combine a fan with an air conditioner, you can massively reduce your electricity use and be just as comfortable, whether that's in your office or in your home. And I think governments have a role here in helping people understand what their choices are, that it's not just kind of all or nothing. Either I can't afford an air conditioner or I can't. We need to allow people to have that access, but in a way that's as efficient and affordable and sustainable as possible, so that the costs in terms of building out grids, building out power stations, curtailing emissions are minimised, while at the same time the benefits to people are maximised.
Okay, Brian Motherway, thanks very much for joining us.
Thank you.